All right, take a look at your opener today. Talks about, is this following shape a rectangle? So what we're looking at here, as far as that rectangle would go, a lot of people want to look at this and say, okay, it looks like it, and yeah, these opposite sides are equal. However, there is a specific property that has to be there for a rectangle. And that's what the second half of chapter 8 gets into here, is we really need to break down what makes our shapes what we say it is. Right? We can't just say because it looks like it or it has this type of property. Right? There's certain properties that make it unique. And that's going to be the difference. Our shapes, they have a bunch of different properties, but there's going to be a unique feature of it that's going to make it what we say it is. For a rectangle, what we're going to learn today is for a rectangle, we need to have right angles. There is nothing here showing that I have right angles at all. Right? All they're saying here is that those opposite sides are equal. Well, that could very easily be a parallelogram instead. Right? So, what we have here is not a rectangle. Okay? We're going to look at three different types of parallelograms here in 8.4. The parallelograms we are going to look at. The first one is going to be a rhombus. Now, a rhombus is a parallelogram, which means it'll have all those 5 properties we talked about when we introduced a parallelogram. Opposite sides are equal. Opposite angles are equal. Opposite sides are parallel. Consecutive angles are supplementary. The diagonals will bisect each other. Those are those properties we talked about with the parallelogram. However, it's going to have one unique property. The thing that makes something a rhombus is actually the fact that there are 4 congruent sides. Right? Now, most people grow up learning that, okay, if I have 4 congruent sides, that's my square. Now, that's not going to be your square. Right? That is actually going to be your rhombus. Right? As we talked about in the opener, your rectangle is a parallelogram, meaning it has opposite sides being equal, opposite sides being parallel, opposite angles being equal. All those properties are still there, but there's one unique property to it, and that's that it has 4 right angles. Now, you'll see these numbers I have written there, that negative 3 over 2 and the positive 2 over 3. Those are the slopes. Remember, to make a right angle, the slopes must be what we call opposite reciprocals of each other. That's how we check with your slopes to see if you have right angles. Now, your square, it's actually the most specific quadrilateral you can have. Not only are there 4 congruent sides, we also need the 4 right angles. So when you look at your quadrilateral, we're going to talk about different types of quadrilaterals. In 8.3, we did our parallelogram. Now, today we're going to look at 3 types of parallelograms. As we talked about, we're going to talk about your rhombus, which means we're going to have 4 congruent sides. We are going to talk about your rectangle, meaning you are going to have 4 right angles. And if you merge the 2 together, that's when we get our square. 4 congruent sides and 4 right angles. So each of our shapes has a distinct property to it. If you wanted your parallelogram, there were your 5 properties we could look back at. Any of those properties we've talked about will show you have a parallelogram. If the opposite sides are equal, you can say you have a parallelogram. If the opposite angles are congruent, you can say it's a parallelogram. As for our 3 shapes today, your rhombus, in order to show something's a rhombus, you need to show that it has 4 congruent sides, which means you need to find the 4 lengths. If I give you the points, you're going to have to use your distance formula to get those lengths. If you're trying to show something as a rectangle instead, We are showing that it has the 4 right angles, which means your 4 slopes are what you would need. And those slopes will have to be opposite reciprocals. Something like 2 over 3 and negative 3 over 2. If you want your square instead, you need both of those features. You'll need the 4 lengths and the 4 slopes, because it'll need the 4 congruent sides and the 4 right angles. So you need the properties of a rhombus and of a rectangle. Sorry about that. All right, it says for any rhombus RSTV, decide whether the statement is always or sometimes true. It says draw a sketch to explain your reasoning. So here's my rhombus RSTV. For A, they want to know, is it always or sometimes true that angle S is congruent to angle V? Now, a rhombus is a parallelogram. So it will hold all the properties of a parallelogram. One of those properties was that the opposite angles are congruent. So this is always true. The other one is angle T with angle V. Always or sometimes true that these will be congruent. Well, the thing that has to be true about these consecutive interior angles is these are going to have to add the 180. Well, the only time that happens is when they are both 90. So that is a sometimes true. All right, let's take a look at that next problem then. It says classify your quadrilateral here. So I got the 127 degrees. I have 4 congruent sides here. So that will make it a rhombus. Now, a square could have 4 congruent. A square would also have 4 congruent sides, but I would need the 4 right angles. Since the 127 degrees is there, I do not have the 4 right angles. So it's a rhombus because there's 4 congruent sides. It's not a square because I do not have the right angles to go with it. Right? The next one there says, for any square CDEF, is it always or sometimes true that CD is congruent to DE? Well, in a square, all of your sides are congruent, so it will always be true, since there are 4 congruent sides in your square. Right? It says a quadrilateral has 4 congruent sides and 4 congruent angles. Classify the quadrilateral. 4 congruent sides, that makes it a rhombus. 4 congruent angles means it has 4 right angles. That would make it a rectangle. A shape that is both a rhombus and a rectangle is your square. Now, a couple quick ideas about these shapes. Some other ideas we need to go over. The first one here says a parallelogram is a rhombus if and only if the diagonals are perpendicular. So another shape to know about your rhombus is these diagonals are going to intersect to form right angles. So those diagonals are perpendicular. Another idea for a rhombus talks about these opposite angles. Now, these opposite angles that are there, maybe this angle A was 100 degrees to start with. That would mean that angle B was 80 degrees. Angle C was 100 degrees. My big angle ADC here would be 80 degrees. What your diagonals do, your diagonals are going to cut these angles in half. Meaning this will be 50 with 50, 40 and 40, 50 and 50, 40 and 40. It says the diagonals will bisect those opposite angles. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. Right, so that's what we're looking at there. Next one says a parallelogram is a rectangle if and only if its diagonals are congruent. So in a rectangle, these diagonals are going to be the same length, meaning that AC will be equal to BD. In example 3, it says sketch rhombus FGHJ and list everything we know. Now, we're not going to list everything we know because we could actually sit here for quite a long time going over that. So just to take a look at a few things. So we know that there are 4 congruent sides. That's what makes it a rhombus. Right? That's its defining feature. However, we just learned some other things about it. We know the diagonals are perpendicular. We know the diagonals, bisect the opposite angles. Right? Those are the new properties we learned today. However, a rhombus is a parallelogram. So all those properties that a parallelogram had, a rhombus will also have. Such as opposite angles are congruent. Angle F is congruent to angle H. Angle J is congruent to angle G. Right? The opposite sides are congruent. FG is congruent to JH. FJ is congruent to GH. Right? We can talk about the opposite sides being parallel. FG is parallel to JH. FJ is parallel to GH. Right? We can talk about the consecutive angles being supplementary. Angle F plus angle G equals 180. Right? There's a lot of different things we can write down. We'll stop right there. Taking a look at our last example then. It says you're building a frame for a painting. The measures of the frame are shown. It says the frame must be a rectangle. Given the measurements in the diagram, can we assume it is? The only measurements we know, we got the 20 with the 20. We got the 16 with the 16. So we have the opposite sides being congruent. That does not make a rectangle. The thing you need for a rectangle, there are no right angles. That's the measurements we need. Now, for part B, it says you measure the diagonals of the frame. Each one is about 25.6 inches. So these two diagonals are congruent. What can we conclude about it? Well, it is a parallelogram because the opposite sides are congruent. It's a parallelogram with congruent diagonals. We just learned earlier in the period. A parallelogram is a rectangle if and only if its diagonals are congruent. In this parallelogram, if my diagonals are congruent, it will make it a rectangle. All right, taking a look at your homework then, getting some practice in. Your homework is pages 537 to 538. The numbers 3 to 14. We'll do 19 to 29. We're going to make it the odds only. All right. If you have questions, please let me know. Other than that, have a good day, everyone.